In question 5, we are given two equations. G of x is equal to 4 cosine of 1/4 pi x, and f of x is equal to 2x squared minus 6x plus 4. Those two curves create a region that is called R. To find the area of R, we're going to use the equation, or the integral, with a lower limit at a and an upper limit at b, of the top curve minus the bottom curve, which is g of x minus f of x dx. Where they intersect is the x values of the integral and the lower and upper limits, which is 0 and 2. And then we just plugged in the equations g of x and f of x. In the second step, all we did was distribute the negative, and then next we have to take the antiderivative of both equations to find the area. So the antiderivative is area equals 4 times 4 over pi sine of pi over 4x minus 2/3 x to the third plus 3x squared minus 4x. And we are going to evaluate that integral from 0 to 2 because that is where they intersect. So we plug in 2 and then 0.
In part 5b it says, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line, y equals 4. So in this we'll be using the washer method, which is the area outside minus the area of the inside, and then we will plug that into pi r squared, which is right here, and make sure you include the entire equation in the brackets or else you will not get the correct solution.
The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square, shown here. Write but do not evaluate an integral expression that gives the volume of the solid. So for the area of a square, you do side squared, and for this equation, you have g of x minus f of x, and you plug that into the volume equation, and with your equations you get the integral from 0 to 2 is equal to 4 cosine pi over 4x minus 2x squared minus 6x plus 4 all squared dx.